Hello again. Let's talk about equation of a plane. So let's write it in this color. Equation equation of plane of a plane. So what is the equation of a plane? So I'm going to give you the formula first and give you the intuition behind the formula. So we have a an arbitrary constant x plus, let's switch colors, b y. B again is an arbitrary constant, and c arbitrary constant again, and d is an arbitrary constant. So what's the idea behind this? So let's go back to pre-calculus around algebra 1 or algebra 2, and let's bring out, oops, this is from the last video. Alright, let's draw the y-axis and the z-axis. Oh no, the x-axis and the y-axis. Alright, this is the x-axis, this is the y-axis, and if you remember, you should remember that the equation of a line is y mx plus b, y mx plus b, where m is an arbitrary constant and just so happens to represent the slope. So this is an arbitrary constant. So let's transform this equation a bit. Let's do this. This is transform apparently. Looks like a car for some reason. Alright, let's transform this equation to look somewhat similar to the equation of a plane. Alright, so let's see, y is equal to negative m, x equals b, and let's substitute m. M is, or let's say a is equal to negative m. Now we have a x equals b plus y, and the constant of y in this case is 1. So let's substitute it in. Let's put let's put let's say let's see let's put in a neutral letter. Let's call it, there are no neutral letters, huh? Let's call it V for Vincent. Alright, V. Again, these are constants. I could have used C, now that I think about it. Alright, so do you see a pattern, or it's not really a pattern, it's more of a similarity or something. So we have a constant, we have a variable, we have another constant, we have another variable, we have another constant, another variable, and at the other side of the equation we have one constant. So that's the basic idea of it, and to put to give you an idea what these vectors could be. That is an overused color. Let's use this. That's used too. Alright. These things can form the normal vector to the plane. So this is the normal vector to your plane. Normal vector to your plane. Alright, so what does that look like? So it's going to be equal to a comma b comma c, and if you want to dot it with x, y, and z, you'll get this equation exactly, and that's also equal to d. And d is basically kind of like the b here, or the b here. It's similar yet not. It's similar. So if I have a plane, of course not an airplane. If I have a plane, in the three-dimensional graph, so let's color it in this beautiful color, or maybe yellow. If we have a plane, its equation would be exactly that equation again: ax plus by plus c equals d. So, and the normal vector the normal vector is its constant components. So that is the equation of a plane, and I'm going to talk about what do you call it, tangent planes, in the next video. Bye bye.